2 basketball games today. I really want to shoot 50% or better. I should make a plan. I can use the scientific method to help me prepare for my 2 games.
If I prepare properly and ensure my ball is at the right KPA, then I will be prepared to shoot 50% or better.
Alright, let's break this down. We're going to use a scientific method to see if Josh's preparation will help him shoot 50% or better.
The scientific method is a step-by-step process used to test a question or problem. It starts with an observation which Josh made when he realized he had 2 games coming up today.
Josh then came up with a hypothesis. Josh predicted that if he prepares well and makes sure his basketball is at the right pressure, he then should shoot 50% or better.
And from that we made a prediction. Josh expects that getting ready and having a well-inflated ball will help him play at his best.
After that, we gathered data. Griffin will track every shot Josh takes and calculate his final shooting percentage.
Finally, we analyze the results. If Josh shoots 50% or better, our hypothesis was correct. If he didn't, we have to figure out why and what could have affected his performance.
Just like in science, we controlled as many factors as we could, like making sure the basketball was at the right KPA.
But there are always outside variables, like maybe the other team played great defense, or maybe Josh was just having an off day.
The ideal basketball pressure is between 51.7 and 58.6 kPa. kPa stands for kilopascal, which measures how much air is pressing against the walls of the basketball. If the pressure is too low, the ball won't bounce properly because there won't be enough force pushing back when it hits the ground. On the other hand, too much pressure makes the ball harder and bouncier, which can lead to bad passes or missed shots. Right at 57 kPa. This will give Josh the best possible performance.
We're using dimensional analysis to convert the pressure of the basketball from kPa to ATM.
As you can see here, the original pressure of the basketball was 57 kPa. We then have to divide it by 101.3 kPa and then multiply it by 1 ATM. This will then give us the pressure of the basketball in ATMs. And the pressure is
0.56 ATM.
Let's move on to the experiment, where Josh plays both games while we track his shooting percentage.
Now it's time to get ready for my experiment and get dressed.
Let's go, boys. Done. Now let's move on to the games. This is the metric conversion to show the feet of Josh's free throw to inches.
So we first do a 1.5 times 10 to the first times 12 inches divided by a 1 foot to get our answer of
180 inches.
oh.
To save the move. Oh, blocked by James! LeBron James! So much pressure.
What the hell?
Yeah!
After both games, Josh made 3 of 9 shots. That gives him a shooting percentage of 33.3%.
The ball pressure was ideal, giving me the best chance for a consistent shooting percentage.
Having everything ready reduces stress before the games.
The scientific method helped us test and analyze our results.
Our hypothesis was incorrect, but there was other outside variables that were out of our control.
This includes good defense from the other teams and Josh having an off day.
Science and basketball make a great team.